For decades, even the most powerful computers were essentially acting as advisors. They could process data at incredible speeds, but the physical world stayed paused, waiting for a human to actually pull the lever. If software generated a perfect 3D design, an engineer still had to manually translate that file into instructions the factory hardware could understand. The same friction existed in commerce. Even when an algorithm identified a critical supply need, a human was required to physically authorize the transaction and move the money. This mandatory human buffer, the need for us to translate digital thought into physical action, acted as the fixed speed limit of the global economy. We are currently watching that buffer disappear. Artificial intelligence is moving from a tool we use into the active architecture that runs the system itself. Until very recently, AI remained contained because it couldn't navigate the messy, unpredictable physics of a factory or the complex regulations of high-stakes finance. Hardware breakthroughs are now granting these systems direct physical reach and financial autonomy, removing the need for a human intermediary. The paradigm of human-operated tools is being replaced by a structure of autonomous, self-executing systems. Consider the modern factory floor, an environment defined by high variability and constant, unpredictable physical shifts. A workflow called sim-to-real is solving this unpredictability by training AI in a way that bypasses traditional human programming. Inside this digital twin environment, the AI trains through millions of iterative cycles, mastering a task before it ever interacts with physical hardware. Once the optimal movement is perfected, that training data is locked and transferred directly into the physical robot. The robot then executes the maneuver in the messy factory environment, driven entirely by its simulated experience rather than manual human code. Industry leaders like ABB and Tulip are using this loop to eliminate the months of delay that used to exist between designing a part and building it. In this model, digital thought translates into real-world action instantly, collapsing the traditional manufacturing timeline. This same collapse is happening in the digital economy. We are seeing the rise of agentic systems, AI that has graduated from generating text to making independent economic decisions. As companies like Stripe embed financial capabilities directly into the AI software stack, the AI no longer needs to ask for permission to spend. When an agent identifies a system requirement, it autonomously initiates the purchase, acting as its own economic buyer. This machine-to-machine commerce is replacing traditional subscriptions with usage-based billing, where agents pay in micro-increments for exactly what they consume. This shift creates a landscape of automated fraud patterns, where defenses must be as autonomous as the agents they are trying to stop. These applications have moved beyond software products. They are independent actors buying and selling in the global market. These physical breakthroughs and economic shifts are merging into a single global network. AI is no longer a tool we pick up. It is an autonomous peer operating inside the system. We can now see a loop where an agent designs a product, a sim-to-real robot builds it, and the software autonomously executes the trade. This change is forcing corporations to dismantle their existing models of risk and revenue and rebuild them for a world that moves at machine speed. In this architecture, data is the strategic fuel that powers every turn of the acceleration loop. Success in this environment requires a total shift in strategy, as companies learn to operate in an economy where machines are both the primary labor force and the primary consumers.